One of the most important concepts in C language is pointers. What makes the C language is more powerful? I can say that it is a pointer. But it is considered as the most difficult concept to understand. Any students, okay, unless they are not smart enough, they tend to avoid this pointer concept. If any questions are coming from the pointer, I think they will do that one just to avoid it. The thing is that the pointer concept is not that much used in the other programming languages. But if I look at the C language, what makes the C language more powerful? What makes C language more machine friendly? I can say that it is because of the concept of the pointer. So how do we explain the concept of pointer in an easy manner? That is what I am trying to do the thing. So when I try to declare a variable, for example, int I is equal to 5, that means I am declaring a variable int, a variable I of the type integer, and this value is equal to 5. This is looks very simple, but for the system, what is going to be the meaning of this one? In the system, it is going to be like this. I think a memory location is going to be created. I can say that a memory location is going to be reserved. Okay? And this memory location is going to be named as an I. Okay? And the value that I am going to store in this memory location is equal to 5. Okay? I can say this one, this is going to be name of the location, name of location. The second one is going to be value in the location. So now the next question is going to be where in memory actually this value is going to be stored. So it is going to be the random. I cannot say that this is going to be stored in this particular location or particular address or something. It is going to be keep on changing depending upon how the system behaves. So in this particular time, I can say that this is going to be stored in a particular location 1000. This is an arbitrary number. That means that the system is going to store the value 5 in a memory location 5. Then I can call this as is going to be the address of the location. It's okay. So when we try to declare a variable to print the value that is stored in a particular location, we are using a statement, and this is known as a function. Function is known as the printf function. Printf function. So how we are going to print the value that is stored in the particular location I, we can say that %d, that is a format conversion character. I can say that value of I is, okay, I say the I. Then what it is going to happen when you execute this program, I get the value 5 here. If you look at the printf, %d, value of I is, what value it is going to do, it will print the value 5 here. I'm going to give it another statement. What is the purpose of this statement? I just want to retrieve the address. I just want to retrieve the address wherein this particular value 5 is going to be stored, and it is known as the address of the location. And how do we get the address of the location? I can say that %u, because sometimes it is going to be the big number, the value of, I can say the address. Address of location is equal to address of I is, I can say that ampersand of I. So what it returns? It returns 1000. So if you look at this, both the statement, I can say that the first statement returns the value that is kept in the variable I. So printf %d, value of I is equal to 5. If I look at the second statement, printf %u, address of I is equal to ampersand of I. That means it returns the address of the location. So what is this? I can see a different character. In C language, this is an operator. I can say that there are two operators are there. One is going to be the ampersand sign, is ampersand operator. What it does, it returns the address of the location. It returns the address of the location. And there is another operator is known as, this operator is known as a star operator. This operator is known as the star operator, and what it does, it returns the value at the address. Value at the address. Okay? There are two special operators. One is an ampersand operator, and second one is the star operator. The ampersand operator is going to return the address, and the star operator is going to return the value at the address. If I put in a different way, for example, here what I did, I have just given the variable name. What it does, the statement returns the value that is kept in that address. Now there are two operators here. One is a star operator, one is a ampersand operator, another one is a star operator. If I combine both, for example, if I write star of ampersand, what does it mean? The value that is kept in the particular address or particular location I. What does it mean that? That means that it will return the value that is kept in the variable I. How it is going to return the value? First, it returns the address by using the ampersand sign. Again, it returns the value, that means by using the star operator. Now, I'm going to have another statement here. Printf, percentage D, value of I. Value of I is, I can write star of ampersand of I. Now look at here, again it returns the value 5. Okay. If you look at the statement, the first and 3, both the statement returns the same value. The first statement, the value is equal to 5. That is a normal statement we use in the programming language. If you look at the third one also returns the same value. This is a way the system will understand. I can say this is a way the system is going to understand when we try to print the value that is stored in a particular location. So what does it mean that star of ampersand of I? Once again, the star of ampersand of I, it means that take the address of this location I and take the value that is stored in the address. That means to know the value of a particular location, it takes a look at the address, then it returns a value that is stored in that particular address. So I can say that both this is going to be same. So when we try to print any particular value, how the system is going to behave, and this is the way the system is going to behave. This is going to be the basic of the pointer operator. If you know the things, we can move to the next level of understanding of the pointer concept. Now, I'm going to delete this. Now, look at here. I'm going to write something again, the same thing I write again. I declare a variable int I is equal to 5. I can say I, again it is going to be saved in a location 1000, and the value that is stored in the particular location is going to be 5. There is another variable I am going to declare here. This name of this variable is equal to j. I have another variable. The name of the variable is equal to j. What the j contains? What is the value of the j? The value of the j is equal to 1000. What does it mean that? J is going to be a different type of variable. I can say it is not a normal variable. It is a different type of variable. What it does, it contains an address of another variable. I is a normal variable, it contains a value 5. But there is a relationship with I and j. J is a normal variable, but J contains what? J contains the address of this particular location. Again, this is a variable. This is different from the normal variable, but it is again has to be stored in the memory location. Let me say that it is going to be 2000. Okay, if look at the I and J, is there any similarity? Is there any difference between these two variables? There is a huge difference between these two variables I and J. I is considered as a normal variable, but J is not a normal variable. It is because J contains not the normal value, but J contains an address of another variable. Here the address of another variable is I. So how we can make it and how we can declare this variable J? That is a major important thing. How we are going to declare the variable J? I can say that one, since J is not a normal variable, J is a variable, it contains the address, and this is known as a pointer type variable. So I can declare this pointer type variable as by using a operator, by using a symbol, I can say that word J. Here the star is going to be an operator, and here the star is going to be a symbol itself. So what is the meaning of this? The meaning of this one is J is a variable. So what is the type of variable? It is not a normal variable, but it is a pointer type of variable. What it cannot contain the normal value, but it can contain only the address. So what it will be? I can say that one, J is equal to ampersand of I. Just look at this one, these three statements. This is the declaration part, the first one. The first is going to be declaring the variable, the normal variable int I is equal to 5. The second one is I am declaring another type of variable. And what is this speciality with this variable? It is not a normal variable, it is a pointer type of variable. So that is why I have given a star of J. What the J contains? J contains the address of I. The J contains the address of I. Now let us try to understand the relationship between this I and J by trying to print out the value of both the I and both the J, and trying to print out the value of the address of I or value of the I in relationship with the J. When you try to do this one, we can understand the relationship between I and J. So normally, I think the previous years, just before, we tried to print the value of I by using a statement. The statement is equal to printf percentage D value of I. Okay, then we give this comma, we give the value I. So we got the value 5. We got the value 5. We try to print the value of I again in a different mechanism by using the two operator. The operators are ampersand and star. I can say this one, percentage D value of I may say this one, star of ampersand of I. Again we are getting the value 5. This is very clear to us. I think we learned these two statements just before, but is it possible, now the question is going to be, is it possible to print the value of I by using J? And this is going to be a very interesting thing, and at the same time it is going to be the very difficult thing to understand. What is J? What is J? J contains ampersand of I. J contains an address. So if you know the address, see that J contains the address, that means ampersand of J is what? J contains an address. If we know the address, what we need to do to take the value? we can extract the value by using another operator that we learned, the star operator. So we can print the value of I by using j. I can say that one printf percentage d value of I can say that one star of j. I get the value 5. This is something we need to understand. How do we get the same value 5? By using a pointer type of variable j. Now look at here, what is j? This is we need to understand. We have made a relationship between j and I by using the statement j is equal to ampersand of I. Then what is j? J is an address. If j is an address of what? Address of I. J is an address of another variable I. That means j contains 1000. This 1000 is pointing to this particular location. If you know this address, see, if you know this address, what we need to do? We can extract the value by using which operator? By using the star operator. Now look at here. Star j means what? The star of ampersand of I, because j is equal to ampersand of I. See, I have established a relationship between I and j here. I am going to print the value that is stored in the variable I by using another variable j. This j is a pointer type of variable. J contains the address of the variable I. So I am established a relationship between I and j by using the statement. Now I get the value j. Now, how I am going to print the address? The printf percentage u address of I can say that ampersand of I, and what it is going to be done? 1000 is going to be print. That means by just using the ampersand sign, what I am trying to do, I print the address of I. But can I print this address by using j? And that is also possible. It is because the value of j is what? Value of j is again the address of I. So I can say this printf ampersand of u address of I is equal to, I can say j, again I am going to print 1000. See, I just want to print j. What is j? J contains a certain value. What value it contains? J contains the value 1000. What is 1000? 1000 is again the address of I. See, I am printing the address of I. This is a very important thing. Then how do I print the printf percentage u address of j? I can say that one ampersand of j, and it is going to print 2000. See, this statement, understanding the sixth statement is very important thing to know the first level of the point type of concept. Normally, I will do the explanation once again to understand what is going to be the pointer and what we are trying to do the first level of pointer. I haven't moved to the second level of pointer. I just moved to the first level of pointer. I try to establish a relationship between two variables. The one variable is a normal variable, and second variable is a pointer type of variable. What is the second type of pointer type of variable? It is a reference variable or the pointer type of variable that can be declared by using a symbol star j. So we have made j as a pointer type of variable. If we have made a variable as a pointer type of variable, what does it mean? It can contain only the address. It cannot contain the normal address. That is why we say j is equal to ampersand of I. It means that j will contain the address of I. You see, the j contains address of I. That means 1000. And j is again located in another memory location. It is known as a 2000. Now, if you come to this statement, if you try to understand this statement, I think our first level of understanding the pointer is successful. What is the first statement? The first statement is we are just trying to print the value of an I. That is a normal statement we used to do in any programming. So I can say that print the value of I. The value that is stored in the location is going to be printed, we get the value 5. But we learned that we can get the value of a particular location by using the two operators. The first operator is an ampersand operator. A second operator is known as the star operator. If I look at the second statement, star of ampersand of I, that means I is a normal variable. Ampersand of I is an address of this location. And star of ampersand of I, it means that value that is stored in this location I. The value that is stored in the address I, again it returns a value 5. If you try to understand the third statement, that is a very crucial statement here. I am trying to print the value of I by using j. What is j? J is an ampersand of I. That means it's already an address. Now we know that if you know the address, I can retrieve the value that is stored in that particular address by using star. So I can say that one star of j. J is an ampersand of I, and trying to retrieve the value in the particular location by using the word star, the star of j, I get the value 5. So this one 5, the both statement, we see that one we established a relationship between I and j. Now, what is going to be the next statement? The next two statement is I am trying to get the address of this first location. I can say that one ampersand of I, and what is going to be the again I try to find the address of the normal variable I by using j. You print address of I, just print j, because value of j is again the address of I. We get the 1000 and print of percentage of u, address of j is equal to star of j, it becomes 2000. So this is the first level of the pointer. Now if you move to the second level, if you try to understand this statement, I think we are successful to understand the basic of the pointer type. Now let us try to move to the next level of the pointer. If you move each level, I think that is going to be more and more difficult, but if you know the picture matters a lot. What is this picture and what is this picture, that matters a lot. I am going to do something different here. I have another variable. Let me say that one. I have another variable. This variable I call it as k, I, J, k. What j contains? J contains 2000. Okay, j contains 2000 and j is going to be located in a particular memory address. It is known as 3000. This is going to be more weird. This is going to be more scary also then. I have another variable k. What k contains? K contains a value 2. But there is a relationship between k and j. K contains an address of a pointer type variable. K contains an address of a pointer type variable. Here, j contains address of another variable. But here, k contains the address of what? Not a normal variable, but it contains address of another pointer type variable. And this k is located in a memory. It is known as 3000. And here comes the difficult. What is this k? We have to declare the variable k. How we are able to declare? I can say that one. I can say another variable int star of k. I'm going to make a relationship between I, G and k. J contains ampersand of I and k contains, k is what? Ampersand of j. Okay, and this is very important thing. And just trying to explain the relationship between the three variables, and these three variables are different in nature. The three variables are different in the value. The first one is going to be the normal variable. Second one is going to be a point type of variable with a single interaction, and third one is going to be again a point type of variable, but the difference between j and k has to be understood properly. What is the k? K contains an address of another variable j, and j is again a variable, j is again a point type of variable, and that is pointing to the normal variable I. If we are able to understand the meaning of I, J, K, I think we are able to understand what actually or what exactly the pointer is going to work in a system. Now, if I look at this statement, I have done like this. The question is going to be, can I print the value of I by using K? Can I print the value of I by using K? Now the question, what is K? That is a very important thing. What is K? K is a point type variable. K is a point type variable. It contains the address. So I am going to write K is equal to point type variable. It contains ampersand of j. K contains what? K contains value of k is equal to 2000. The value of k is equal to 2000. But we understand k is not a normal variable. What is the k? K is again a point type of variable. It contains an address. What is an address? 2000. If you know the address, to get the value of the address, what we need to do? We have to use the star operator. Star of k. It is equal to star of ampersand of j. What is the star of k? K is 2000. What 2000 contains? 2 contains 1000. It becomes is equal to 1000. See the star of k. By using this k, by using the operator star, I am able to retrieve the value of the j. But again, what is j? J is again an address. So what we need to do, if I know the address of something is, by using again the star operator, what I can do one thing, I can extract the real value that is kept. So I can say that one star of k is equal to star of ampersand of j. I close this, I may close this, and this equal to 5. That means by using the k, I am trying to extract the value of 5. So I can write like this: printf percentage d value of I is equal to star of k, and we are getting the value 5. And this is very important thing. To understand this statement, we need to refer this statement, these three statements. I'm trying to explain once again how it is going to be. K is a pointer type of variable. What k does? K contains the address, ampersand of j, because ampersand is always retain the address. So k is equal to ampersand of j. What is there? It contains 2000. But if we know the address, what we can do? We can print the value that is stored in the address by using an operator. That operator is going to be star operator. So star of k. What I am trying to do? I am trying to get the value that is stored in this particular location 2000. So I can say this, I'll get the value 1000. Again 1000 is going to be another address. If you know the address, I can extract the value by using again another star, the star of k. I can define this as star of ampersand of j. It means that this is going to locate this particular location. I am going to extract the value 5. It is known as star of k. The value 5 is going to be given. So this is a way I have established the relationship between I, the relation between j and k. Here again I say this is a normal variable, and this is a first interaction variable, that means a single pointer variable, and this is a double pointer variable. What do you mean by the double pointer variable? A variable which contains another address of another variable, which again contains address of another variable. That is why we have a star of k. Again, by using this statement, I can print the value of 2000 again. How do I print the value of 2000 again? I can print. Here I have print ampersand of j is equal to 2000. Okay. Here what I can do, one thing. Here itself I can, one more way I can print the 2000. Just print the k. I can see. If I give just k, I can print the 2000. Now if I look at here, j is equal to 1000. If I print the star of k, see the star of k, what it does? It again print the 1000. So I can print the value, I can print the address in a different way by using either by using the variable I, or using the variable j, or using the variable k. So this is actually the way the system works when we use the different type of variables. I'm trying to explain the pointer, wherein the pointer, this is a different type of variable. It contains the address of another variable. I'm trying to explain two operator. One is an ampersand operator, other one is a star operator. You have to understand the meaning of the ampersand operator and the star operator. The ampersand operator will return an address. The star operator will return the value that is stored in the address. By using these two operators, by using this linkage, we can try to explain the pointer type of variable. By using this pointer type of variable, what actually we can do that one, we can better and better, our programming skills. If a normal program will take, for example, I can say that 25 to 30 lines to write the program, but if you are using this pointer concept efficiently, we can better the performance. That's the first thing. Second thing, we can reduce the number of the statement that we may use in our program. And happy to explain this pointer concept. I hope you understood the pointer.